Okay, simplifying rational expressions is pretty easy. What you need to understand first of all is that a rational expression is simply a fraction. So that's a fancy name for a fraction, is a rational expression. And usually the way we're going to go about solving these things is to find the GCF of each part of the fraction. So for example, what's the greatest common factor of 6 and 9? Well, that would be 3. So what we want to do is break the numerator and denominator into factors, one of which is 3. Well, if one of the factors of 9 is 3, then the other one also happens to match and also be 3. The idea behind finding the greatest common factor is that once you have matching factors here, they're going to reduce down and be worth 1. And whatever factors are left over after you've reduced out that 1 will be the factors that are left over is the reduced version of your rational expression or the reduced form of your fraction, rational expression. Over here, the greatest common factor of 14 would be 7, so 7 is common to both 14 and 35, but it's 14 times 2, 7 times 2 is 14, and 7 times 5 would be 35. Having that greatest common factor of 7 to both pieces here, again, that would cancel out and be worth 1, leaving 2 over 5 as your reduced form of the fraction. Now, one thing that you don't have to do with these fractions that you will have to do with future ones very simply is this. Notice on the bottom that the 9 has a number. There's no x or y, no variable there, as is the same thing with 35. When you start to have variables in the bottom of your rational expressions, you're then going to have to find undefined values, because remember, the bottom of the fraction can never be worth 0 totally. So if you plug in a number into the bottom of your fraction, and it works out to be a total value of 0, it becomes undefined, and that's something we can't have. But it's not going to happen when you have just 9 or 35 in the bottom, because quite simply, 9 is always worth 9, which is never 0. And the same idea behind 35.